Welcome to Efiwe, excellence without stress.
Good day, listeners. This is Efiwe, excellence without stress, and my name is Adibite Holuwasho. I will be taking you some Jamb topic based on the Jamb syllabus that makes you to pass Jamb without stress. Today, we'll be going on the first topic, which is number-based system. Number-based system. Now, when we are talking about number-based system, this is one of the topic we believe that it gives students problem as far as mathematics syllabus is concerned. Now, what is number-based system? Number-based system is also known as positional numeral system. It is a way of representing numbers using a specific base or radix. In this system, numbers are expressed using digits and their positions relative to their base. Although this is not a new topic to you as well, but I will just take you through a way of solving this problem on number base that will be easier for you and that will make you to be fast. You develop some techniques that you can use to solve a number-based system. But there are some basic things I want you to understand here. That when we are talking about base 2 number-based system, is also known as binary system, as it has been posted to you on your screen here. We also have base 8. We also have base 16, and these are number-based system which have a specific name that is being called. And which means that base 16 is called hexadecimal, base 8 is called octa, while base 2 is called binary number. You still have many of them that they have a specific name being given. But I will also let you know that there are some things or there are some formation that as far as number base is concerned, we can have. That's why I'm taking you through the next one, which is the example of number-based system based on their formation. So we can have a number-based system in form of 11101 base 2. We can also have 241 base 5. We can also have 53b base 12. And firstly, I will like to tell you one thing about this, that when we are talking about number-based system, each of the numerals that we have here must not be greater than the base. If it's greater, then number base did not exist. But basically we have 241, and that is how it's supposed to be pronounced. 241 base 5, not 241, because most of us we don't normally take cognizance of this. So firstly, we say 241 base 5. And secondly, you see my third example. And my third example is 53b base 12. You ask me, why do we use b? Although we use b for some specific reason. You know that number-based system, we cannot pronounce numerals together. Like when I have 10, I can't pronounce it as 10. But sometimes we can have 10 in formation or in forming a number-based system. In forming a number-based system, I can have 10, I can have 11, I can have 12, I can have 13, I can have 14, I can have 15. And from my right up here, I have from letter A to F. A represents 10, B represents 11, C represents 12, D represents 13, and to F, which I have it to 15, and so on and so forth. So we have B to be 10. So if we want to deal with their expansion form, we know how to write it, and I'm going to show you as well on how to write this form. So basically, if I don't want to write 241 base 10 in form of this, I can also write it using some formations like this, using something like this, I can write something like this. I can write something like this: 241 base 10, or I write 241 base 2. In fact, sorry, this one will not be accepted because each of the numerals here, 1 is up to the base, 4 is greater than it. So which means that this is not acceptable in number base system, but this is acceptable. We can also have something like this: 241. Let's have base 6. We can write our 6 like this. You can see, which means that I can write it in words and I can write it in numerals. But this is not acceptable. This is acceptable because each of the numerals that I have here is greater. Is lesser than the base. So which means that if I have a number that is greater, something like this, that is greater than the base, definitely it is not accepted. This is accepted and this is also accepted. So let's get back to how to convert a number based system. So let's get back. So how to convert a number based system? Firstly, I will be talking about conversion of number based system. And before I go, any number that exists in terms of numerals, they have what we call a natural base, which is base 10. So obviously, if I'm writing something like this, let's take for example 24. Let's take for example 24. Now 24 is having a natural base, which is base 10. So which means that sometimes I can put it, sometimes I might decide not to put it. So that's what it means by natural base. So take note of this that I've talked about. And now let's move to conversion to base 10. How we can convert a number base in base 10. Obviously, to convert a number base to base 10, definitely our number base will not be in base 10, which means that our number base can be in another formation of base or another base. In order to convert, if our number base can actually be in another form, then we convert it to base 10. So how do we convert a number base to base 10? We convert a number base to base 10 using expansion form. And that is what I have actually programmed on our screen, and that is 4132 base 10. How can we convert 4132 base to base 10? So which means that obviously this 4132 is not in base 10. That is what it means. So which means that I am now converting this 4132 to base 10. That is what I want to do now. So how do we do that? Now I have tried to develop a simple technique on our screen, which means that I can take it one after the other. That 4132, how do I expand it? So because whenever we want to convert 4132 to base 10 or any number base that is not in base 10 before, how do I convert it to base 10? So which means that I use expansion form. Then what do? I make use of expansion form in form of this. So let me take you through how to use expansion form. Yeah. Now if I want to use expansion form for this, here I have 4132. So this number is a form of base 10. So how do I go about it? So which means that I'm going to use expansion form, but before I use expansion form, I'm going to create a kind of what we call power here, that is reading from 0. I have 1 here, I have power 2 here, I have power 3 here. So here, how do I go about this? So this number, which I will take from 4, will be multiplied by 10, will be raised to the power of 3. The second number as well, raised to the power of 2. The third number. So how do I go about this? So I will write 4 times 10 raised to the power of 3. We have plus we have 1 times 10 raised to the power of 3 as well. We have plus as well. We have plus 3 times 10 raised to the power of sorry, this is supposed to be raised to the power of 2. Pardon me. So this is supposed to be the raised power of 2. So here we have raised to the power of 2. We have raised to the power of 2, and here we have raised to the power of 1. Here we have plus 2 times 10 raised to the power of 0. So by doing this, we have used expansion form. We have just extended the number base system. So this is the first approach to use in order to convert to the base 10. Although it's in base 10 already, but we still use this to show us how to convert to base 10. So basically we have this. So if we have this, we can do the same thing to the second one. Here we have base B, and that's what we have here, base B. So you can see that I did the same thing for this. So what if we have a decimal number? Sometimes we can have a decimal number. How do we place the power? This should be in base 10. Let's assume that this is in base 10. So we have 572.43. 572.43. Let me take you through this as well. 572.43. So this will be the second one. 572.43. So how do I introduce powers here? This one, all the powers are positive, but this, so far we have a point here, which means that we have a bridge here. Then the powers here we go from negative here. So we have -1 here, we have -2. But here, this one will be the positive part. Although we call this whole number part, we call this one negative number part, which can be also be called negative integers. So we have a 0 here, we have 1, and we have 2. So how can I expand this? This is expansion form converted to base 10. Remember that this is base 10 already, but I still want to convert to base 10. So this is the first approach I will use. So I will have 5 times the base, which is 10, raised to the power of this power of 2, plus 7 times 10 raised to the power of 1, plus 2 times 10 raised to the power of 0, plus remember, don't mind the point here, it's still going to be addition. So we have 4 times 10 raised to the power of -1. We have plus 3 times 10 raised to the power of -2. So that's what we have for expansion form. So the next that we'll be checking on today is okay, good, it's examples. So based on what I have taught you, so I will try the first one, you try the second one, but I will still show you the solution. So you can see basically here I use bracket, but it's still the same thing as multiplication. You can see the first example. We have to convert the following numbers to base 10. So which means that each of these numbers, they are in one. The first one is in base 2, the second one is in base 7, the third one is in base 2 as well. So don't get confused. This others base can also be written in words. They can also be written in words. So here we take the first one. You can see how we go about it. We have the first number 1 times 2, which is the base. Now the first thing we do is to put powers here. So which means that this guy here, we have the first year. Okay, let me show you. So basically we have 1100101 base 2. So which means that I'm going to be writing this here. Okay, so basically we have this guy 1111001 101 base 2. So we can write it like this as well. Base 2, we can write it like this. So here we are going to put the powers, which is 0 1 2 3 4 5 and 6. So which means that in order to illustrate this, we use the expansion form, which is the same thing as what we have here, which is the same thing as what we have here. We have the power of 6, the power of 5, the power of 4, 3, 2, 1 and 0, like what I have done previously. So here now we'll be having the base 2 multiplied to this multiplied to this multiplied to this. So 2 raised to power 6 give me 64, 2 raised to power 5 give me 32, 2 raised to power 16 it's 4 give me 16. Obviously we have a result like this. So here we'll be having 1 times 64, which is this 64. We have 1 times 32, which is 32. We have this result as well. When you add everything together, you are going to have 101 base 10. So we don't call it like that. Obviously we call it 101 base 10. 101 base 10. So that's what we have. We also have it for this as well, 3154 base 7. 3154 base 7. So we follow the same approach to solve your question like this as well. If you follow the same approach, you have this. So we also have the third one, which is 1101.111 base 2. You can see now that obviously we are going to have negative powers after the decimal point here. Negative power after the decimal point. So which means that this one takes minus 1, this one takes minus 2, minus 3. So if you have more than that, then we have minus 4, minus 5, minus 6 and so on like that. So we have a positive a number here called whole number that starts from 0, 1, 2, 3. So we have it here as well, which is 0, 1, 2, 3, and this ones has been illustrated based on their respective powers. So we have 2 raised to power 3, which gives us 8, 2 raised to power 2, which gives us 4. We have 2 raised to power 1, which returns to 2. We have 2 raised to power 0, which is 1. We have this as well and this. So obviously we are going to have this guy as 2 raised to power minus 1. And take note, all these powers can also be illustrated as this so that we don't get confused. So if I have a negative power, obviously if I have a negative power like 2 raised to power minus 1, we can actually do it as this. We have 1 all over 2 raised to power 1 all over 1 over 2 raised to power 1, which is the same thing as this guy here. That's 1 over 2, because 2 raised to power 1 give me 2, and this one returning to 0. This one returning to 0.5. This one returning to 0.5, and that's what we are having in the bracket here there. And we can still have something like this, 2 raised to power minus 2, and this negative power gives 1 all over. Take note. And we have the remaining numbers, which is 2 raised to power 2, and this gives 1 over 4, obviously gives 0.25. And these are the things that we have in the bracket here. These are the things that we have inside the bracket here in terms of the negative number. So when you take the multiplication one after the other, we get the remaining result. We have this when you had this result together. So obviously this is how we convert from one number base to the other. So you can try we have the same thing on C to D. So we can also try, this is drill 1 that we have. We can also try all this on our own. You can try this on your own, the A to D question. So we can convert all this into base 10. So when we try all this on our own, it will make us to know our capability based on this topic on how to convert. So next on our agenda here is what we see here, and we want to know how to convert from base 10. We want to know how to convert from base 10 to another base. So obviously these are the procedure that we are to follow, and the first one is we divide the number respectively by their new base units until we have the dividend to be 0. So obviously we have the dividend and we have the divisor. So when we are talking about the dividend, this is what we mean. So when we are talking about the dividend, okay, obviously if we are talking about dividend, we are talking about dividend, we are talking about the result that we actually get. We have a divisor, we have the dividend. So if we have let's say we have 10. If I have let me start from here. If I have like 10 divided by 2, this one is known as dividend, and this guy here, which is 2, is known as the divisor. So that is what we have there. So we understand the concept of dividend. That shows that what we want to divide, and what we are using to divide is what we call the divisor. So obviously let's quickly get back to what we are talking about here. So here we write the remainder after each division. We obtain the new number by writing the remainder in reverse order. So here now we are going to convert the first one. Here we have 375 base 10 to base 6. So which means that we be having all these number base in base 10 already. So we want to convert it to another base which is not in base 10. So the base that we want to convert it to, we call it another base which is not in base 10. Take note. So we also have 73 base 10 to base 2. We want to convert 73 base 10 to base 2. We want to convert 375 base 10 to base 2. So obviously what are we going to have here? Now I also call this type of method remainder method or long division method. Long division method in such a way that we'll be writing our remainders one after the other. So how do we go through this? So that's what I want to show this morning, and this one will be found on my next page, which is this. So we can see this solution, the first solution and the second solution. So which means that we now place it like this. So we have 6 as the divisor that we divide throughout until we have our dividend to be 0, and we have the remainder which happens to be our final answer. So we have 6 divided by 375. We have 59, which remain 3. we use 6 again to divide 59, which we have 9, we have remainder 5. We use 6 to divide 9, which you have 1 remainder 3. We use 6 to divide 1. Obviously 6 cannot go in 1. Obviously we are going to have 0, and we have remainder 1. 6 cannot go in 0, which we make us to stop here, and we have our final answer from downward upward. So somebody will ask me that, why do we take our answer from the downward part to the upward part? Obviously, when we expand this guy to base 10, we are going to have this. But when we take our answer from 3531, if we expand that answer like that, we cannot get this guy back, which is 375. So obviously, if we take our answer from here, we express it back to base 10 from base 6, we should get 357. So we can try that on our own from what we have learned before. So the same thing as this B part, we follow the same procedure to get our final answer. So this is our drill 2 here. You can actually test your ability on this remainder long division in order to have our remainder as our final answer. You can try this for your own, and all our drills will have the answers at the final level of this lesson. So we have another thing that I want to look at here, which is conversion from one base to another. That's what we want to look at now. To convert from one base to a new base, or we say that to convert from base 10 to a new base, we use the long division method that we've been taught earlier. But here, to convert from one base to another, we first convert to base 10. That's the first thing. If that number base is not in base 10, definitely we have to convert to base 10. So that is our first conversion as far as number base is concerned. So when you see any number, be it in form of any base, it can be in form of base B, it can be in form of base of any variable. And when we talk about variable, we are talking about letters in English language. So don't get confused when you are talking about base or when we are talking about variable. So our base can be in terms of a base. So whenever we are talking about number base, the first conversion that we see there should be in base 10 if that number is not in base 10. But if it is in base 10, we don't need to bother ourselves, because if it's in base 10, if we try to convert the same base which is in base 10 to base 10, we still get the same result. We can try it on our own and we see that what I'm saying is very true. So here now we want to convert to another base entirely from one base that is not in base 10. We want to convert it to another base. So how do we go through that? So the first thing we do is to convert that base number to base 10. That's the first thing. So as you can see on my screen here, we have this guy here, which is 101101 base 2. We want to convert it to base 6. So far it's in base 2, definitely we use expansion form to convert to base 10. That's the first thing we do here. So that is why we have 45 base 10. You can see we have 45 base 10. So here we have expansion form. Obviously we are going to put the power first. We have 2 raised to power 5, 2 raised to power 4. So I think we have dealt with this before. So we follow the same procedure to convert to base 10. So if you cannot get it, you can check the previous you can rewind your video and you check what we have done before in order to convert to base 10. So you can see what will happen here. We'll convert to base 10 first. So we now convert back to base 6. So if we want to convert any number in base 10 to another base which is base 6, so we use long division method, and that is what we have here. We have here as our remainder. Take note. So we have our remainder, and we have talked about this before, and at the end of the day we have 113 base 6, which give us the same result. So I want us to go through this, and we have this as well. and that is the next thing we'll be talking about, how to determine an unknown base. So obviously we can determine an unknown base if we have the number base in form of equation. And what do we call equation? When there is presence of equal sign in any question that we are giving in mathematics, then we call that expression, the whole expression has equation. So which means that an expression can also be called an equation. So we have to have that in our mind. So we have some question here, they are in form of equation, and those questions we are to provide solutions to them. And how do we provide solution? We have unknown there, which is in form of base b. So we can have the first one here, and that is 305 base b equals 152 base 10. So which means that this guy has been converted to base 10. So you can see my solution. I don't bother myself to convert 152 to base 10 again. So I told you earlier that any number that we have in number base, the first thing to do is to use base 10 conversion, which is expansion form first. That's the first thing. Use expansion form if that number base is not in base 10. So obviously our 305 here is not in form of base 10. That's why you can see us using expansion form for our conversion first. You see we have expansion form here. We have 0 as the power here, 1 as the power here, and 2 as the power here. So we have 3 times b raised power 2. So we use this procedure. You can see that here we have b raised power 0 to be 1, which because anything raised power 0 except 0, anything raised power 0 except 0, it will give us 1. Remember my words. I said except 0 will give us 1. So here now we have b raised power 0, which will give us 1. So obviously we have 5 times 1, which is give us 5 here. So we have 0 times everything here will give us 0. So that's why it's not existing here again. So when we have our equation like this, so we have b raised power of 3b raised power of 2 plus 5 equals to 152. So when we try to take when we subtract 5 from the both sides, so that this 5 will go, when we subtract 5 from the both sides, we have this. So the next thing is to divide both sides by 3, and we have this guy here. When we divide both sides by 3, we have this guy here, and we still have square here. So we take note by squaring both sides. So take notes, we are dealing with positive side here, because obviously when we square both sides, we are going to have is either we have positive or negative, but because we are dealing with positive side here, we don't have a negative base, we have a positive base. So that's why we have square root of 49. Obviously we have 7 here. So we can follow the same procedure for this. You can see that here I need to use expansion form here, the second side of my the right hand side here. So you can see that what I actually did here is to expand it using expansion form, because my number is not in base 10, is in base 4. So you follow the same procedure to have our result. Thank you. So here we have our drills. So you can try this on our drill 3. We have our drills here, so you can try this on your own to check whether you have actually gotten what we have said so far. So next we are going to addition and subtraction of number base system. Obviously we'll be checking the question together. So let's take the first one. We have 1101 base 2. We are asked to add this together. We have 1011 1 base 2, and we have this guy here 111 base 2. So obviously we are going to be adding them together. So this one comes first because it's a higher number here. So we have 101 1. We have the second guy here, which is this. We have 1101, and you have to be mindful of how you place your number. Take note. And we have the last guy here, which is this, which is 111 everything in base 2. So we are asked to add it together, so I can put my addition sign here. Once we have been taught in GSS1, even in primary school, we have 1 plus 1, which is 10, and 10 plus 1, which is 11. We can actually use that method, but today I'm going to be taking you through a simple method that we can actually use again, which will result to the same answer. So here I'm going to be having 1 plus 1, which is 2, so that even if you are just learning mathematics for the very first time, we are going to have it in an easier way. So which means that in easy way, pardon me for that grammar. So we have 1 plus 1, which is 2, plus 1, which is 3. So our result is 3. Remember that our answer for any number base must not be up to this base or greater than the base. So obviously we are going to have 3. We are going to have 3, which is the answer. I'm not going to write 3 here. 3, I'm going to divide it with our base, which is 2, and our remainder will be the final answer. So which means I'm going to be having 1, remainder 1. So this remainder I'm going to keep on writing, which is 1. So you can try that with what you have learned before. That is 1 plus 1, which is 2, plus 3, which is 1 plus 1, which is 10, plus 1, which is 11. So you write to 1. You can see it's still the same method. It's still following the same approach, just that the method I'm using for you might have not seen it before, but it's still follow the same way. So we have this 1 as answer, in which I'm going to have here. Then I will have 1 plus 1, which is 2, plus 0, which is 2, plus 1, which is 3 again. So I still have the same 3, which is 3 divided by the base, which is 2. So I will have the same thing I have here. So which means I'm going to still write the remainder here, which is my remainder will continue to be my final answer. So which we should take note. So which means that the answer I've gotten here, which is this, I'm going to put it here, and this one will be a little bit different, and let's learn how to actually solve a question like this. So here we have 1 plus 1, which is 2, plus 1, which is 3, plus 1, which is 4. So which means that 4 is greater than the base here. So I'm going to have 4 divided by 2, which is the answer will give me 2, but remainder 0. So the remainder will be here, which is 0, and now we transfer the 2 here. I will transfer the 2 here. So which means that here I will have 2 plus 0, which is 2, plus 1, which is 3. You can see I have 3 again. So let me use this one. So 3 divided by 2 will still give me, divided by the base will still give me 1, remainder 1. So I have remainder here, which is 1, and I have this 1 here will be transferred here, and I have 1 plus 1, which is 2. It's still the same thing as the base, which means that we cannot write it. So we must follow the procedure. So 2 divided by 2, which is 1, remainder what, 0. So I put my remainder here, which is 0. So far I don't have anything to add again, and I have an answer here, which is 1. So I just drop the 1 here. So this becomes my answer, everything in base 2. So you can try the other method and you see that we are going to get the same answer. So my final answer here is 101011 base 2, which is going to give us the same result. So take note, you can use this procedure. So you can also use this procedure for the second part here as well, which is 1123 base 4 in addition to this. So let me also put you through on that, and let's see how it works. Okay, I'm solving my second question here, which is 2 3 base 4. We also had it with plus 3 2 1 base 4. Obviously we have a a correct number base here. So how do we put the solution down? So we have 1 1 2 3, and we have in addition to 3 2 1. Everything is in base 4. So we want to add it together. So we are going to use the same method that we have learnt before. So which means that 3 plus 1, which is 4, we cannot write 4 as the answer because our result must not be equal to the base. So we have 4 divided by 4, which will give me 1, remainder what? 0. So here we have 0. So we have take this one, we take it to the second part here. You can see. So we have 2 plus 1 plus 2, which is 3, plus 2, which is 5. So we have 5 divided by the base, which is 4. That's 1, remainder 1. So you have 1 here. So we have this guy here, carry this 1 here. So obviously we are going to have 1 here from my explanation. So we have 1 plus 1, which is 2 plus 3, which is 5 again. So we follow the same procedure. So we have 1 here. We have we carry the 1 here. So we have 1 plus 1, which is 2. Obviously 2 is not up to the base, so we have 2 here. So we have everything in base 4. This becomes our final answer. This becomes our final answer. So here we have the second question, and we have the third question, which combines the two operations together, which is addition and subtraction. So here I'm going to solve it here as well. Okay, so here we have the third one. Wow. So I'll be taking us through the third one as well. So that's number 3, and I have this guy here, that is 212 base 3. We have it minus 121 base 3. We have this guy also. We have 222 base 3. So how do I go about this? This is also taken from Jamb past question. So I'm just going to put you through how we can solve something like this. So I can actually deal with BODMAS, which means that in BODMAS, addition comes before subtraction. So which means I'm going to be adding this guy and this guy together, and this guy together. So which means that we have this guy, this 222 base 3 owns the plus, and we have 212 here base 3. So let's add these guys together. We'll have this we have this. So the two of them are in base 3. So we have this guy. So if we have something like this and they are not in equal base, the first thing we have to do is to convert everything to base 10. We take normal addition and subtraction, and the answer that we get, we now convert it back to the required base. So that's what we are going to do to that one. So we should take note of that. So let's add this. Let's go through this. We have 2 plus 2, which is 4. We can pause the video and you try it yourself before you now see the workings here. So we have 2 plus 2, which is 4. We can write it. So we have 4 divided by the base, which will give me 1, remainder 1. So you have 1 here. We carry the answer, the result that we get here, carry it here. So when we add everything here, we get 4. So the same thing that we repair here, we have 4 divided the result, which is 4 divided by 3. That's 1, remainder 1 as well. So you allow me to write 1 here. You carry the result again, you carry it here, but this time around we are going to get 5. We are going to get 5. So which means that our result is 5, which is different now. So we have 5 divided by 3, which is the base. We have 1 remainder 2. 1 remainder 2. So we are going to put our remainder here first before we now consider the answer. So far we don't have anything to add here again, so we drop the answer here, which is 1. So this becomes our, sorry, we have from here, after we dealt with, after the addition part, we have our result. Now we take the subtraction part. After our addition part, we take the subtraction part, which is 1 to 1. We subtract 1 to 1 from this result. So how do we go about that? So here we have 1 to 1 here. We have our 1 2, 1, 1. We have it subtracted by 1, 2, 1. Everything is in base 3. So here we now subtract. So how do we take subtraction in number base? We have not done that before. So let's see how we take subtraction in number base that is greater than 0, 0 and 1. That is greater than 1. So here we have 1 minus 1, which is obviously 0. 1 minus 1 obviously 0. But 1 minus 2, 1 is lesser than 2. So 1 is greater than 2, rather. 1 is greater than this guy here. We have minus 2 here. 1 minus 2. Take note. 1 minus 2. So 1 is greater than minus 2. So obviously, we cannot perform that operation like that. Then we need to borrow 1 here. So if we borrow 1 from 2 and it's coming here, so we borrow 1 here, we take the 1 here. But what we are saying here is that we are taking in terms of the base. So taking 1 here from 2, this guy will reduce to 1. This 2 will reduce to 1. Then we are taking that 1 here, but the 1 that we are taking here will be in terms of the base. So obviously, when I'm taking 1 here, definitely I'm taking 3 automatically, because taking 1 from these 2 will be in terms of the base. So obviously, I'm taking 3. I'm not taking 3 here. I'm taking 1, but it will be in terms of this guy, which is the base. So taking 1 here, which means that I'm taking 3. Taking 1 here means I'm taking 3. So which means that if I had 3 here, this guy becomes 4. So here I'm going to have 4 minus 2, which is 2. 4 minus 2, which is 2. So if I've taken 1 here in terms of the base, I've taken 1 here. This guy reduced to 1, in which I have 1 minus 1, which obviously that is 0. And we have the last guy here, which is 1. 1 minus nothing here, which will give me 1. So here I've been able to finalize my answer, and my final answer is 1020 base 3. 1020 base 3. So that ends the subtraction part of this question. So here we are going to see some example. So you can perform this drill on your own. You can do it on your own. You can do it. You can see that 1 plus 1 is 2. You divide by the base, which is 2. You get the remainder 0. So far we are not going to add anything. So obviously the first guy here will be 1 0 1 0, and obviously all the number base here is in base 2. So let's try that on our own and see whether we can get the result on our part. So here we also have this drill that you can try on your own. This is actually in base 6. You can see the question here by the right hand side here. So this is actually in base 6. So we can also try that on our own, and we can see this example here. So you can pause the video and try this example on your own and see whether you are going to get it on your own part. We have both subtraction and addition here, in which we have talked about earlier. So we can also try it on our own. So now we are going to the multiplication part of this topic, multiplication and division. So it is performing the same way we have done for base 10. So obviously you can use 2 methods to actually tackle this. So but here I'm going to be using 1 method, and the method I'm going to be using is very unique, obviously. So here I'm going to be having 11011 base 2 multiplied by 101 base 2. So I'll be using this to explain. Obviously you are going to use 1 first to multiply. 1 times 1 will give me 1. 1 times 1 will give me 1 again. 1 times 0 will give me 0. So we are going to use this first guy, which is 1, to multiply through, and we are still going to get the same result. So you can try it. We use the second, which is 0. 0 times all these guy here. So we are still going to get 0 for everything. And we have the third part, which is 1 times everything, which is the same result that we're going to get. So the next thing is to add everything together. We had everything together. So obviously is in base 2. So I think when we add everything together, we are going to get that last result. We add up everything, so that 1 plus 0 plus 1, which is 2. The remainder method I taught you earlier, we can use it and use it to get the same result. So that is what we have. Now for the division part. For the division part, I'm not going to be taking you through the long division method. Let's use, I'm not going to be taking you through the long division method, but I'm going to be taking you through one shortcut. By converting each number base to base 10, I divide and I convert it back to base 2. So obviously that is what we are going to be having now. So let's see how we can deal with division of number base system. So we have 110 base 2 divided by 10 base 2, and that is what we are going to be seeing now. So let's see. Okay, now we are going to deal with the division form of the number base, and here we have a question, which is 110 base 2 divided by 10 base 2. So obviously I'm going to convert this to base 10, which is 110 base 2. I have 0 here, 1 and 2. So we have 1 times 2 raised to power 2. So we have plus 1 times 2 raised to power 1. We have plus 0 times 2 raised to power 0. So here I'm going to be having 1 times 4, because 2 raised to power 2 is 4. I'm going to be having 1 times 2, because 2 raised to power 1 is 2. I'm going to be having plus 0 times 2 raised to power 0 is 1. So here obviously I'm going to be having 1 times 4, which is 4, plus 2 plus obviously 0, because 0 times 1 is 0. So here we are going to having 6 base 10. So the second one, I'm going to be having 10 base 2, which is I'm going to convert this one to base 10 as well. That will be 0 1. I'm having 1 times 2 raised to power 1 plus 0 times 2 raised to power 0. So here the result gives 1 times 2, which is 2 raised to power 1, which is 2, plus 0 times 1. So here I'm going to be having 2 plus 0, which is 2 base 10. So if I'm only writing 2, it's still the same thing as base 10. So this gives here, this implies that I'm going to be having something like this. 6 base 10 divided by 2 base 10. So it's the same thing as me writing 6 divided by 2, because it's a base 10. Base 10 can be in form of any number. In 500 base, I can have 100 base 10, any number, everything in base 10. Even though I'm not using base 10, everything is in base 10. So this gives 6 divided by 2, which this guy will give me 3 base 10. Take note. So now I'm going to now convert it back to the base that is coming from. So far my question is in base 2. Definitely I have to return my answer in base 2. So here we are going to have this guy here. It implies that we are going to have something like this, long division method, which means that I'm going to have my remainder here, which means that this guy here is going to be like 3, and I have my divisor here, and that is 2. That I want to convert it to. So here I'm going to have 2 divided by 3, in which is going to give me 1 remainder 1. So when I use 2 divide 3, I will have 1 remainder 1. I will use 2 to continue. Obviously this cannot go. I have 0, and this one will be transferred here. This one will be transferred here, which is this. So obviously I'm going to take my result from downward upward. From what I've explained before, I'm going to have my result for 3 base 10 to be 1 base 2. So this concludes my answer that therefore I'm going to have 110 base 2 divided by 10 base 2 to be equal to 11 base 2. So this hence my result. So on this part we can actually try some things by ourselves. This is the question. That's the 6. This is the question. So you can take the first one by subtracting 3310 base 5 from 1144 base 2. Sorry, 1442 base 5. So the second question, if 263 plus 441 equals 714, what is the number base being used? What's the number base being used? So you can assume that the number base being used is n. So which means that you put base n everything, you expand it, you solve it in form of equation. When you expand it one after the other, you now solve it in form of equation and you get the value of n. So you can also divide and you can also multiply using the previous method I've taught you. And this should be the solution to everything. This is our solution. So for our drill 1, drill 2, drill 3, we have the solution. For drill 6, we have the solution. So you must be able to get all these answers one after the other. So we also have the fill in the gaps that you have actually done as well. You can pause the video and check whether all your answers are correct. We also have this. Our answer is correct. So this becomes this comes to the end of our class. I hope we enjoy the class. Thank you